So this is a problem I stole out of another book, and it's about lost luggage, and the airline is saying at least, well, they're saying 90% of the lost luggage is recovered within 24 hours. So I mean, are they doing better than that? Are they doing worse than that? So they went out and they found that only 103 out of the 122 people had their baggage returned on time, or the next day. So they're trying to test, does this cast doubt on the airline's claim? Well, let's jump back a couple of weeks, and back in chapter 5, we learned about, or 6, we learned about the normal approximation for the binomial distribution, and that's what this is. Now, a couple of things we should check is I have at least 10 or at least 5 yeses, and we have what, 90? What is that? 99? No. 21, I guess I can't subtract, 19 no's, so those are both bigger than 5 or 10, depending on whatever you want to use, so that checks. This came from a random sample. They don't tell us whether it's a random sample, where I guess we can assume it is, so that's an issue. We also know that, what's the other stipulation? Is this 122 people, is that less than 10% of the overall population of airline flyers? And I would certainly say that the population of airline flyers is more than, I mean, that's certainly less than 10% of that. So I think we're good. It's got all the conditions met. So the central limit theorem applies, and so which case we can use that normal approximation of the mean, and that's what the mean is, and that's what the standard deviation is. If we calculate a z-score for the 103 people, we get a little over 2 standard deviations below that supposed mean. So, I mean, that's more than 2. It's not much over 2 standard deviations away. So, I think it casts doubt on the airline's claim. But that's not even doing a significance test. And what I want you to see is a significance test is just another way to look at these results. How to do this problem? It's a significance test problem. What if so now let's go and go back 1 week. What if I want to treat this as a confidence interval, and I don't know what the true proportion of recovered luggage is, but I do know I got the sample, so let's use that to estimate what the true proportion of recovered luggage is. So at a 90% confidence interval, we got these results, and as you can see, that upper bound is a little less than 90%. Granted, if you round, it's not, but with that many decimal places, it is less than 90%. So just like when we found the z-score before, and we said, well, that's slightly over 2 standard deviations away, we can say, well, at a 90% confidence level, we can say that the true proportion of recovered luggage is less than 90%, and that does cast doubt on the airline's claim. Now, if we do a 95% confidence interval, it captures that 90%, so we couldn't make a case against the airlines. That kind of goes in the same vein of thought that, well, -2 standard deviations, -2.05 standard deviations is not really that, it's just barely over the line, so maybe there isn't something going on there. So you got to kind of weigh that in your mind. So let's approach this now from a hypothesis test point of view. So let's see this. So we already know the claim is that, well, maybe we ought to write the claim. So the airline is claiming that 90% or better of their lost luggage is returned. So I guess to counterclaim that, so that'll be our HO, that the airline company is right, that 90% or better support the 90% or better of the percent of the luggage is returned within 24 hours, and an alternative hypothesis is to disprove that. So we're going to say less than 0.9, and then if we do the test statistic, well, that just happens to be, you're going to have seen this number before, you'll see in a minute. So the standard deviation is, let's see, what is that? So we're going to take the 0.9 times 0.1 divided by 122 and take the square root. It just so happens that works out to be the, so when I did this just now, I got 0.0272 if we round. And our p-hat from our sample was 103 out of 122. And that's about 0.844. So to get the z-score, we're going to do 0.844 minus 0.9 all over 0.0272. So I got negative 0.0, let's see, negative 2.058, so negative 2.06, which, if you think about that very first problem when we're treating this as the normal approximation for the binomial distribution, that's the exact same z-score we got. So you see how it's all related. It's really, you've learned how to do this already. Now you're just applying it this way. So what's our p-value? Or we could do critical value. Thinking about our rejection region, if at the 5% level of significance, we've got a one-tailed test, the critical value is negative 1.645. Our test statistic is out beyond that, in the rejection region. We'll reject HO. Looks like, based on this result, the data doesn't support the airline's claim that they return 90% or more of the luggage, lost luggage within 24 hours. Okay, if we do the p-value, I did this earlier on my calculator, I came up with a p-value of 0.02, which is certainly less than the set level of significance. So it looks like the data doesn't support the airline's claim. So what is this all about? Well, we aren't saying that we aren't saying anything about the actual proportion. We don't know if it's 90%. Well, we don't think it's 90%. We think it's less than 90%. What percent it is, we don't know. That would need more testing, more sampling, that kind of thing. Okay, so I hope this helps. Another example helps.